Is Proxima B Earth's cosmic twin? Since its discovery in 2016, the closest exoplanet to Earth has been suspected of hiding an exciting secret. It could be surprisingly similar to our home planet and perhaps even harbor life. Despite its proximity, Proxima B has hidden its true face from us for a long time. But now the James Webb telescope is taking aim at our neighboring world to find out its true background. But what have the astronomers discovered? What is the story behind the mysterious signal from the Proxima Centauri system, which is said to have an artificial origin? And is it true that Webb has tracked down a brightly lit alien metropolis there? Let's start with a little quiz question. How many planets are there actually? 8 or 9, because we're still counting Pluto? Well, not quite. Because we mustn't forget one thing. There are also countless planetary worlds outside our solar systems. We have now discovered no fewer than 6,911 planets in 4,941 systems that orbit a host star other than the Sun. However, the bottom line is that the celestial bodies detected so far are just the tiny tip of the cosmic iceberg. Experts estimate that there are up to 50 billion more planets out there. And that's just in the Milky Way, mind you. And if we now remember that our home galaxy is just one of billions of other galaxies in the universe, a fundamental question arises. Given the overflowing abundance of the cosmos, is it even possible that Earth is the only celestial body to have given rise to life? Many scientists answer what is probably mankind's oldest question with an unequivocal no. And it's only a matter of time before we encounter our extraterrestrial neighbors for the first time. And true to the motto, why wander into the distance when the extraterrestrial is so close? It could be that the next alien civilization is practically slumbering right on our earthly doorstep. After all, no other known exoplanet is as close to us as Proxima B. The distance separating us from this alien world is just 4.2 light years. And let's be honest, what's 4.2 light years? Well, that's 37.84 trillion kilometers, and with our current means, it would take 6,300 years to bridge this enormous distance. Fortunately, mankind is now in the comfortable position of being able to explore the mysteries of space without having to leave its own home planet. And as mentioned at the beginning, we have known about the existence of our closest neighbor to Earth since 2016. We also know that Proxima B by no means orbits solely around its eponymous host star, Proxima Centauri, in the constellation of Centaurus. This is because it is orbited by at least 2 other planets. But how do you even find a celestial body that is over 37 trillion kilometers away from us? Are the James Webb telescopes of our time really so powerful that they can track down these alien worlds directly and capture them on film? Well, not really. But truth is that indirect detection methods have turned out to be the greatest guarantee of success. This applies in particular to the transit method, in which a planet reveals its existence by changing the brightness of its host star as it passes by. In the case of Proxima B, however, it was the so-called radial velocity method that revealed its presence. In simple terms, this detection principle works as follows. A star attracts a planet with its gravity, which therefore orbits it. Conversely, the planet also exerts a tiny gravitational influence on its star, causing it to wobble minimally. And although the stellar dance sometimes only covers a few centimeters, it's enough to tell astronomers that our star charts need a new update. Is Proxima B the Earth 2.0? In order to be included in the list of potentially habitable worlds, a planet must first fulfill a basic requirement. It must be located within the habitable zone of its home system. In other words, it must orbit its star at a distance that allows water to exist on it in a permanently liquid form. However, the mere presence of the elixir of life is by no means enough. Other factors, such as the atmospheric composition or the radiation of the host star, can still thwart the development of life despite all the favorable conditions. But what is the situation in the case of Proxima B? Well, with a mass of 1.17 Earth masses, the celestial body is considered an Earth-like exoplanet. But before we get it wrong, The term Earth-like only refers to rocky planets with a solid surface, without making any statements about their habitability. And while our Earth is known to take 365 days to orbit the Sun once, Proxima B only takes just over 11 days. This is due to the short distance between the exoplanet and its central star. While the average distance between the Sun and Earth is around 150 million kilometers, Proxima B orbits its star at a distance of just 7 million kilometers. In view of this, it is reasonable to assume that it must be scorching hot on the planet's surface. And this is true, but only half of the time. Basically, Proxima Centauri is a red dwarf whose mass is only about 12% of the mass of the Sun. However, the data collected so far indicates that Proxima B has a bound rotation, which means that it always presents one and the same side to its parent star. As a result, the exoplanet is divided into a freezing cold night side and a significantly hotter day side, a circumstance that nips any thought of potential habitability in the bud? Not necessarily, because between these two extreme zones, there could be a narrow strip that actually offers life-friendly conditions. The bottom line is that the sharp contrast could even have a positive influence on the conditions in the twilight zone. The researchers' simulations have shown that the habitable area could draw its supply of liquid water from the glaciers on the night side. These would melt near the twilight zone and thus feed the lakes and rivers. And what about temperature? Well, the experts calculated an equilibrium temperature of minus 39 degrees Celsius. To explain briefly, the equilibrium temperature is the temperature that sets itself after a sufficiently long time in a system. Conversely, however, this does not mean that the equilibrium temperature must also correspond to the surface temperature. Because if Proxima B has an atmosphere, this can be significantly higher as a result of the greenhouse effect, a circumstance that our terrestrial home can also tell us a thing or two about. Without an atmosphere, the Earth's equilibrium temperature would be minus 18 degrees Celsius. Is there life on Proxima B? Well, the answer to this question, or more precisely, to the question of the existence of liquid water, depends on a number of parameters that have not yet been conclusively investigated. Assuming the appropriate orbit and a favorable atmospheric composition, a 2017 simulation came to the conclusion that the cool water on Proxima B could splash around happily. Despite this, the actual habitability of the planet is still hotly disputed, primarily due to the fact that the turbulent activities of the host star could put an end to the development of life. A few years ago, researchers at the University of Colorado observed something that dwarfed everything that had gone before. It has long been known that our sun regularly draws attention to itself with bursts of radiation, so-called flares. However, what the researchers saw flare up on Proxima Centauri was 100 times stronger than any solar flare observed to date. Within a few seconds, the star increased its ultraviolet radiation by a factor of 14,000. In fact, the eruptions there are not only significantly more intense than in our home system, but also much more numerous. Against this background, it can therefore be assumed that the extreme radiation will destroy the entire atmosphere of Proxima B over time, thus destroying any chance of life developing. And yet, if the exoplanet had a social media account, the entry for life relationship would still read, "It's complicated." Because there is a scenario in which Proxima B does not lose its atmosphere to space. To do this, it needs a liquid core that forms a stable magnetic field and thus keeps out the dangerous radiation from the parent star. In this way, the oxygen and water molecules would be kept on the planet, and it's also possible that the celestial body is still drawing from its original supply. In detail, one theory states that the exoplanet was actually formed at a much greater distance from its central star and was only gravitationally captured later. It's also conceivable that there was once 10 times more water on Proxima B than on Earth. And even if the extreme radiation had already robbed 90% of the water, there would still be enough today for a huge ocean covering large parts of the planet's surface. But as you can already imagine, the water temperature would only be moderate in the narrow twilight zone. On the night side, the water would be permanently frozen, while on the day side, it would resemble a bubbling boiling pot. of mysterious signals and artificial city lights. Basically, if there really are highly developed alien civilizations out there, they must have left behind a technical fingerprint. Since 2015, the members of the Breakthrough Listen project have dedicated themselves to the exciting task of tracking down these telltale signals in space. And lo and behold, in 2020, the researchers actually captured a potential radio signal from the Proxima Centauri system, which was immediately suspected of being the signature of a hidden alien race. And then there were headlines claiming that the James Webb telescope had detected a brilliantly bright carpet of artificial city lights on Proxima B. Could it be any clearer? Of course not, because this is clearly a false report. In detail, we are only dealing with the extreme distortion of another exciting discovery. In truth, Webb has uncovered an exciting methane glow show in the realms of the brown dwarf, W1935. And it has nothing to do with extraterrestrial civilizations. And what about the radio signal? Well, in this case too, the analysis painted a sobering picture for all alien enthusiasts. The signal, dubbed BLC-1, was ultimately of terrestrial origin after all. It was created by the distortion of terrestrial radio signals. As a result, the mysterious WOW signal from 1977 remains the most promising candidate when it comes to the question of extraterrestrial messages. Experts are now pinning their hopes on future investigations by the James Webb telescope. And wouldn't it be possible for Webb to take a direct look at Proxima B and capture the exoplanet on film? Well, unfortunately, there is one big problem. The celestial body orbits so close to its star that it can hardly be distinguished from it. However, the researchers are currently looking for a few tricks and lucky circumstances that will allow them to take a close look at the alien world using spectroscopy. And we're going to tell you a trick that will allow you to watch our videos regularly. Simply press the like and subscribe button to stay up to date from now on.